Alright, hi kids, this is lesson 99. Today we're going to be working on another part of math that's geometry. So we're looking at more about spatial reasoning, like pictures and stuff, and seeing how math mixes in. So what I'd like you to do right now, let's have the teacher pause the video. Let's have students write down what's in yellow. Please pause the video here. Alright, so today our goal is, your objective you see right here is I can describe, define, compare, and contrast geometric terms like such as angle, circle, perpendicular line, parallel line, line segment. So there's a lot of definitions. Today's going to be very boring, unfortunately. You're going to be learning about definitions, but you need to know these. It's part of your standards. You need to precisely know them. And the teacher gave you a packet of information, so you'll need to be able to refer to that. I'm going to tell you what to do with that. You can make notes on that, but do not lose this packet, okay? I don't want you to lose it because we need to be able to study from it, and I'm going to talk to you about that, okay? So, we're going to talk about definitions today. Why are definitions so important? We all need to know exactly what we're talking about when we describe things. So, for example, you're playing a sport. Let's say you're playing football, and you're like, oh, you want to talk about who a quarterback is, what a football is, what the line of scrimmage is, what's the lateral, what's a running play, what's a passing play, what is a three-point conversion. Right? We don't know. Not everyone knows the definitions, and so when we talk about football, we need to know what the definitions are so we can understand what the game is doing. Same thing with math. We need to understand what the definitions are of geometry so we understand how to use the math and to apply it. Because this part's going to be pretty fun for some of you. Some of you have been struggling. You're going to really like this. Okay. So here we go. Let's look at the first one. A line. So you don't need to write these down, but you do need to understand the concept. So a line is a connected straight path. It has no thickness and it continues forever in both directions. It forms infinite amount of points. So the first part of it is that this line goes on forever. So if you think about this board or this picture here, this line does not just stop right here. It goes on forever in this direction in a straight line. And it goes off the page, so this line technically keeps going off my screen, right, if I could have it go off the screen. So that's one thing. The next thing about this definition you need to know is that it also has an infinite amount of points. It has a point here, it has a point here, there's a point here, there's a point between these points here, and there's a point between these 2 points here. And if we think about that, there's a point in between these 2 points and these 2 points, and there's a point between these 2 points and these 2 points, and these 2 points, right? You get my picture, right? If I could zoom in, I could put a point everywhere and fill this whole line with points, right? So, my point is that this line has an infinite amount of points, okay? Next one is a plane. Okay, a plane, not like an airplane, but it's like a plane is a flat surface that extends infinitely on all directions with length and width, and it has no thickness. So think about the top of your desk. Your desk is, the top of it is a plane. Of course your desk is limited, but pretend your desk went in infinite directions everywhere. You could imagine it going into forever, and it has no thickness. It's not like a board, it's just a flat plane, okay? And notice that there are 3 points here. So when we have 3 points, we can make a plane. This plane is called plane ABC. We could call this plane ABC. We want to name things that we see, so this is called plane ABC. And just to show you on the last one, like a line, we got a line here. Let's say we gave it 2 points like L and M. We could call this line LM. Okay? Same thing with this one. Okay? Next one. Sorry I'm going quickly here. We're going to go through a lot of these. Point. Okay, point, we already know what it is. It's a specific location. It has no dimension and is represented by a dot. Okay, so A point is a point, like a point on the graph. You're like, where are you at San Dimas High School? We could represent this as a point, point A. Okay, this is called point A. Let's all say point A. Okay, good job. All right, next one is a line segment or segment. So this is like a line, but notice that there are no arrows. Do you notice that there's no arrow after these, right? There's no arrows because it's a segment. It's only a piece of the line. So this is, it has a point at the end, at both ends, and it's called line segment AB. We could call this line segment AB by writing AB and putting a line over it with no arrows at the end. Okay, and it's a portion. If let's read this this definition here. It's a portion of a line consisting of 2 points called endpoints and all points between them. A line segment is named by its endpoints. Okay, line segment, not a line, but a line segment. Look at your line, right? You see how a line has arrows that go forever. Not a line segment. Line segment has points that make it stop. So it's not infinite. Okay, next one, array. Okay, array has, notice that there's a point here, and you might notice there's a point here at the end, and there's an arrow here at the end, right? So, array is a portion of line starting at a particular point, the end point, and extending infinitely in one direction. So, think of this like a sun ray, right? Let's say this was the sun here, and there's light traveling out of it. The light doesn't go through the sun, right? It starts at a point on the sun and moves out, right? So, same thing here. Let's say this was a point S for sun, and let's say this was point E for the earth, right? A ray pointing toward the earth. We call this ray SE, and we'd start with writing S because that's where it starts, and it's going toward E. Draw a line and an arrow at the end. This is called ray SE. Okay? Cool. Sorry going quickly. We got a total of 18 of these, so moving it. Number 6, coplanar. Points, line segments, rays, or shapes that lie in the same plane. Meaning coplanar, meaning they are on the same plane. So let's go back to plane on number 2. You see how there are 3 points on the same plane here? We got point A, B, and C right here. These 3 points are on the same plane. They share the same plane, so they're called coplanar points. Let's all say coplanar. Okay, so when we say coplanar, it means things that are sharing the same plane, or the points that are sharing the same plane. Alright, that's just a term. Get used to saying it. Coplanar. Next one, colinear. Points on the same line. You see how there's a line here? Let's say we had line AC here. Well, line AC may have another point, point B. All 3 points, A, B, and C, are colinear. They share the same line. Next one, number 8, parallel. You kids probably know parallel, right? Think of train tracks when you think of parallel. So we got 2 lines here. We could think of this as line L. So we could say that there's line L here and there's line M. Or you could call this line AB and line MN. Okay? There's 2 ways you could call it. But parallel means are lines that lie in the same plane but do not intersect. They'll never intersect. They're going to go on forever in each direction. Each direction they're going to go on forever, but they're not going to intersect, like train tracks, okay? They are perfectly straight. They will never cross or turn. These are called parallel lines. Okay? Continuing on here. Angle addition postulate. So we're going to talk about this more. But you know, like, let's say we had, think about it like an angle addition postulate like this. Let's say you had a piece of wood here, right? Let's piece of wood is 3 inches, and you had another piece of wood that was 6 inches. When you put them together, what's 3 inches plus 6 inches? Well, you get a bigger piece of wood that's going to be how many pieces, or how many inches? when we glue them together, we're going to have 9 inches, right? Same thing here, but we're talking about angles here. So we have 2 angles inside this. So we have angle PQR, and then we got PQS, and then we got SQR, okay? 3 angles here. Let's say this angle on the inside here was 20 degrees, and the one down here was also 20 degrees. The angle addition postulate says that we could say PQR plus SQR is going to be equal to PQR, or a total of 40 degrees all the way around. So this whole thing would be 40 degrees, okay? That's all we're saying. And it just makes logical sense. Just like when we glue 2 pieces of wood together, we're going to get bigger, longer piece of wood, right? Alright. Continuing on here. Number 10. There's this geometry word called postulate. It's called a postulate. It's a rule. So it is a statement that is accepted and true without any proof, okay? So the idea here is that it's just an unsaid rule. We don't have to prove it. It just is, and we all accept it. Kind of like gravity on Earth. I mean, we could prove that there's gravity on Earth, but we don't need to because we know that we're all being pulled down to the Earth. It is a postulate. It's accepted that there's gravity, and we don't have to prove it because it's already there. Okay? Next is segment addition postulate. Remember I talked about the pieces of wood being added together? Well, this is the same idea here. Let's say we had 2 different line segments. We had line segment AB and line segment BC. Okay? So we had 2 line segments. This one plus this one is going to be equal to the whole one, right? Right? Just like I said, maybe this piece of wood was 3, this one is 6. What's the total going to be equal to? 9. Okay? Here's the definition for it. We want to make sure we are accurate on it. If 3 points A, B, and C are collinear and B is between A and C, then AB plus BC is equal to AC. Segment addition postulate. Continuing on, this is the distance formula. We're going to spend some time going through this, but we'll have this together in our notes. So I'm not going to spend too much time right now on it. But the idea, remember the Pythagorean theorem? Think about the Pythagorean theorem. We have a squared plus b squared is equal to c squared. That's all I want to talk about today. We're going to talk about this more in the next couple lessons from now, okay? Just know that this is here. You're going to have to memorize this, okay? Distance formula. And it's the distance between 2 points on a coordinate plane. Okay, continuing on here, number 13, the midpoint. Okay, so let's say we had a line segment here, line segment AB, okay? And we had a point in the middle. This point C is, if we call it a midpoint, we are assuming it's exactly in the middle. It is our midpoint, okay? So, the definition here, we would definitely want to have the exact definition here, so we all know exactly what we're talking about. The midpoint is the point that divides a line segment into 2 segments that have the same length. So when you see how C is right here in the middle, originally we had a big line segment called AB all the way across. What this does is if we cut it right in half, right at C, we're going to have 2 equal pieces. This one's going to have the same length as this one here. So for example, if AB was all 6 inches all the way across, what do you think each of these pieces will be? 3 inches, right? So we can make these assumptions using the idea or definition of midpoint. 14, segment bisector. Okay, so you may have heard the word bisect before. Bisect means to cut perfectly in half. Okay? So let's look at this picture here. Let's just pretend we had this big line called XZ. I'm going to kind of hide it a little bit here. Let's see if I could do a good job about it. Let's say we had a line segment XZ, right? And then we had a midpoint right here in the middle. Wow. let's say we took another line and we cut it in half. Let's say we made the line a segment bisector. By doing that, right in the middle, this new line TU is going to perfectly cut XZ in half, right? So that means this side of the line will be exactly the same as that side of the line. This is called a segment bisector, okay? That's the concept. Let's read the definition together. Segment bisector is a line, ray, or other figure that passes through the midpoint of a segment and divides the segment into two equal halves. XY is equal to YZ. A bisector implies congruence. Okay? So, that's what a segment bisector is. And congruence, you see this word congruence at the end, that means exactly the same. Congruent means exactly the same. Different, but exactly the same. Just like our desks in our room, when they were brand new, let's just pretend they are all the same. Even though we have 36 different desks in here, they are all congruent, meaning they're all exactly the same. Alright, let's keep going here. We're almost done. Undefined terms. Undefined terms are words that do not have a formal definition, but there is an agreement about what they mean. Like a point. We all know what a point is. It's a point on a graph or on a map. A line. We all know what a line is. We see lines everywhere. And a plane is a flat surface that goes infinitely in all directions with no thickness. These are undefined terms. So it's another definition that we need to know. Midpoint formula. We're going to talk about this in a couple days. Sorry about that. Not crossing it out. Okay. But this is it. You should memorize this, and we're gonna. I'll read the definition for you. It's the formula used to find the point that is in the direct middle of 2 points. X1 and Y1 represent the two coordinates in one of the two coordinate pairs chosen, and X2 and Y2 represent the second pair of coordinates. So the idea is here, like, let's say we had a big graph, and we had 2 points here and here. Where's the midpoint? If I drew like a line in the middle, where would the midpoint be in the middle here? How do we figure that out? Well, this is what we're going to use to figure that out. And you'll have to memorize it, okay? Next one, 17. We have the endpoints of a line segment. So we talked about line segments earlier. We have endpoints. So remember earlier, let's say we had A and B here. A and point B on the endpoints. It is what ends my line as a line segment. And let's read the definition here. It's a point or value that marks the end of an array or one of the ends of a line segment or interval. Okay? Kind of connected to, or it's definitely connected to a line segment, but we want to use this word endpoint. Endpoint. Just like there's an ending point to a game, or there's an endpoint to the diving board, it's an endpoint. Okay? And then we're going to be using a compass here. Here's the last definition. Construction. We'll be doing a lot of construction in here. It's going to challenge you a little bit, but we will be using constructions to help us solve or help us to create new pictures of geometry. And the construction is a method of creating a figure that is considered to be mathematically precise. Figures may be constructed by using a compass and straight edge, geometry software, or folding paper. So that's what a construction is. Okay? You'll see this thing called a compass here. We'll talk about that more. They're sharp, but they make nice circles when they're used properly. Okay? Sorry, that's a long lesson. 20 minutes of me talking about each of these. I suggest you work through these and understand them, and not even work through them, read through them and practice them. This is kind of like flashcards, so you could cut these out and make them flashcards. You could also glue these in your notebook. I'll talk to you about it tomorrow more, but I want you to practice these. You need to memorize these, because these will be on your test, and we're going to refer to them. So let me And here, let's have the groups talk about this as we end the lesson. And then the teacher's going to give you guidance on what to do next, okay? So again, everyone in their groups are talking about these 4 questions right now. Take a minute to do that. And maybe after, the teacher could ask the class what they learned and answer these 4 questions, okay? Cool. Thank you, kids. See you later.